this is chapter 5, extension number 1, where we're going to extend what you learned in Math 9. We're going to talk about common factors of a polynomial today. So let's just do a quick review of all these algebraic terms. You know algebraic expressions come in many forms. Here are some examples, right? 3x squared, 5a minus 2b plus 3, m cubed plus n squared minus 0.5p. Now each individual item is really called a term. And a term actually can be split up into two parts. There is a variable, right, that's like the letter, and something called the coefficient. That's the number in front of the variable. So let's just practice labeling the coefficients and variables for each of these terms in example number 1. 8x, what's the coefficient? That's the number in front of the variable. Yeah, so 8. The variable must be x. What about negative 4d to the power 5? Well, the coefficient is negative 4. The variable, you can say, is just d to the power 5. How about the coefficient? Yeah, that's 1/3. The variable in this case, you can say x squared y z to the power 5. The coefficient in this case for d. Now, if you're thinking there's no number in front and you wrote down 0, I'm saying, oops, don't do that, because 0 times b is not equal to b. Actually, 1 times b actually equals to b. So the coefficient here is actually 1, where the variable is b. And finally, for e, pi is a constant, it's a number, still a coefficient, but of course there's no variable. No variable. Okay, this is actually a constant, what they call a number, a constant. So a term, or sum of terms, in which all the variables have whole number exponents are called polynomials. Okay, the key thing is whole number exponents. None of that fractional stuff that we were dealing with, I think, in chapter 2, extension activities. Now, we can also classify polynomials in categories. So something called a monomial. Oops, M-O-N. Monomial. That, of course, means there is only one term. So an example would be 5x squared, right? There's something called a binomial. That, of course, is two terms. So let's do 3x squared y minus 6x, like that. There is something called a trinomial, which is three terms. So, I don't know, x squared minus 7x plus 10. And then there's just the general idea of a polynomial, and that just means many terms. Okay, now it doesn't really say specifically this has to be like 3 or more, but just many terms. Okay, so it could be 4 terms, right? Could be less than that too, right? Could be 2 terms, so on and so forth. Okay, now some more terminology here. There's something called the degree. Now, the degree of a term is the sum of the exponents of the variables, all the variables in the term. So in this case, 3x squared to the power 5, the exponents are 2 and 5. We have to add them together, so we have a degree of 7. Okay? And the degree of a polynomial, so that's all those terms put together, is the highest degree of all the terms. So if you look at example number A, if I ask you for, or 2A, I ask you for the degree of the polynomial. Look, this is degree 1, degree 2. The highest one is, of course, 2, so the answer is just 2. Here the degree is 2. Here the degree, careful, x to the power 1, 1 plus 4. That one is degree 5, so the highest degree here is 5. And for this one here, woohoo! I'll let you think about this. I combine these together, that looks like it's 10. Don't forget z to the power 1, that's 1, so 2 plus 8 plus 1 is 11. This is 12, so the degree must be, in this case, 12. Okay? And then, hopefully you remember how to multiply these things. Can you actually do it? A monomial by a monomial, hopefully you remember, is 3 times negative 5, that's negative 15. And then x squared times x to the power 6 is x to the power 8. So, in essence, we just multiply coefficients together, and then we also multiplied the variable parts together. Okay. If I have a monomial by a polynomial, hopefully you can see that we're going to actually distribute. I don't remember doing this in Math 9, but we're going to distribute this over. So negative 2 times, or negative 2x times x cubed is negative 2x to the power of 4, because x times x cubed is x to the power of 4. Negative 2 times 4 is negative 8. X times x cubed, or x times x squared is x cubed. And then also here, negative 2 times negative 1 is positive 2. X times x is x squared with a y. So the key idea here is to distribute the monomial into all the polynomial terms. Okay? Alright, let's move on. Next page. Now, note that the multiplication of two terms can be expressed geometrically as an area of a rectangle, right? Like 4 times 5. If I think about like me drawing, I can have 4 things on this side. So I don't know, 1, 2, 3, 4, and multiplying by 5. So 1, 2, 3, 4, 5. And I can fill in everything, right? So 4 times 5 here. Hopefully you can see 1, 2, oops, I did 6. Ha ha ha, that messes you up. Sorry. 4 times 5, of course, gives you 20. Now I can do the same thing with 2 bracket x plus 3, because 2, once again, is those 2. Oh, hold on here. I should have done it this way. 4 is represented by, 1, 2, 3, 4, right? 5 is represented by 1, 2, 3, 4, 5. So when I multiply, I get that. In this case, 2 would be represented by, those 2. And the x is represented by that big long rod. Yes, doing those algebra tiles. Hopefully your teacher did that with you in Math 9. That's an x, and then the plus 3. Here we go. That represents x plus 3. So if I do it like this, and I now draw in my area of a rectangle, look, I get a rod, that's x, another one, that's x, so that's 2x. I get 1, 2, 3, 4, 5, 6, plus 6. Okay. So in the above example, I'm going to say we ended, not started, we ended with the polynomial 2x plus 6. And when we drew out the rectangles, and those little squares, I guess, you notice that the sides of each rectangle represented the factors of the polynomial, the 2 and the x plus 3. So the idea is when we write a polynomial as a product of factors, so when I say writing it like something times something, that's what that product of factors is. The idea now is we actually factored the polynomial. And we say that a polynomial is factored fully when the polynomial cannot be factored further. So for today now, what I want to do is see if we can actually factor these binomials. And I want you to actually draw out the algebra tiles as well. Okay? So if I look at 5y plus 10, the idea is I've got 5y, so the y's are those long rods, right? 5 of them. And I got a whole bunch of 10s, so 10 little ones. And our goal is to make a rectangle, and make the most compact rectangle possible. So if you think about 5, I think I can only do 5 rods like this. 1, 2, 3, 4, 5. And if I'd have to distribute the 10, I guess I should distribute 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And notice what we have now here is, on the top, we have an x or a y and a 2, right? So that's a y plus 2. And over here, I just have 1, 2, 3, 4, 5. 5 in terms of 5 small squares. So really what we've said here is 5y plus 10 in my picture is equal to 5, which is the side length, times y plus 2, the other side length. And if I were to use the idea of factoring out the greatest common factor between 5y plus 10, you get the same thing. Because if I take out the greatest common factor, that would be a 5. And then you should be asking yourself, what's 5y divided by 5? That's right, that's just y. What's 10 divided by 5? That's right, that's positive 2. And look, you get the same answer as above in the algebra tile picture. Okay? Same thing with 4b. This time I have 6c squared. So the c squares are those huge rectangles. I have 6 of them. And I have 9 of these rods. That's what I have. Okay, 9 of them. So how can I rearrange these into a nice compact rectangle? You might be thinking, yeah, I like how you did it earlier. 3 big squares in each row. Sure. Now how do I do the 9 rods? I guess I can put them down this way if I wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if that's the case, look at my size here. I've got 1 rod, 2 rod, 3 rods. That's 3c. Got 1 rod, 2 rods, 3 small things. So that's 2c plus 3. So what we've just said here is 6c squared plus 9c can be factored into 3c, that's one side, and then 2c plus 3. Once again, with the idea of the GCF, same idea here. What's the greatest common factor between 6 and 9? That would be 3. How about the c squared and the c? That would be c. And then once again now you say to yourself, 6c squared divided by 3c, what's left over is 2c. And then same thing here, 9c divided by 3c, what's left over is just the 3. Same answer. So if I want to factor this one now, one of the ways you can do this scary trinomial is actually factor each term of the trinomial first if you'd like. And then you can write each term as the product of this greatest common factor and another monomial. So the key thing is to figure out the greatest common factor. Okay, think about the 12 here. 12 can be what? 2 times 2 times 3, I guess. You have your x cubed, y squared, and z. 20 could be 2 times what? 5, I think, with a negative. X cubed, y cubed, z squared. 24. That's what? 2 times 2 times 2. That's 8 times 3. Negative. So x squared, y 4, z cubed. So think about what the greatest common factor would be. I see 2 2's. I guess that's 4. So the GCF, 4. Now think about the x cubed terms now, or x terms. X cubed, x squared. So the greatest common factor there must be, that's right, x squared. Noticing the y's, y squared, y cubed, y 4. The greatest common factor is probably, yeah, y squared. And z squared, z cubed. I think that's just a z. So really what I should be doing is taking this now and factoring out 4x squared, y squared, z. And now what's left over? That's my monomial. That's left over. 12 divided by 4. That's 3. X cubed divided by x squared. That's x. Y squared divided by y squared. That's just 1. Z divided by z. That's just 1. Leave it. Next one. This term, 20 divided by 4. That's 5. X cubed divided by x is just x. Y cubed divided by y is just y. And z squared divided by z is just z. And finally, the last term here, 24 divided by 4, that's 6. X squared divided by x squared is 1. Y to the power of 4 divided by y squared is y squared. And then z cubed divided by z is z squared. And that, my friends, is the final answer, the factored form. Whew! Okay, so here are some more I'd like you to factor, and also example number 7. Okay, so if I ask you to factor these, the key thing is to figure out what the common factor will be. So for number A here, I'm thinking 5x and 15, the common factor is 5. And then ask yourself what's left over. So what's 5x divided by 5? That's just x. What's 15 divided by 5? That's just 3. Done. How about 6b? I see a 6. Now think about it. A squared a. What's the greatest common factor? That's right, just a. And then b cubed, b squared. The common factor is? Yeah, b squared. And now when you divide, let's see what you get. I think we get a, b, minus 3. Okay? You try C, please, on your own. Greatest common factor. 3x. Left with 3x squared minus 4x cubed plus 2. Did you get that? Nice, if you did. I'm thinking about D. It's kind of weird. I know, don't worry. Take out the 1/6. Because you get y squared. And then 5/6 divided by 1/6 just gives you 5, so 5y. And then 7/6 divided by 1/6 is just 7, so that would be fine. Now, E and F are really crazy doozy ones, so let me help you with that. What's the greatest common factor? Now, there's two terms here. Here's the two terms. Can you see how both of these terms have what in common? Yeah, the a minus 2b. So we're going to take that out. And then now what's left over? So think about it. This divided by a minus 2b, what's left over is just the a. And if I take the second term, 5b bracket a minus 2b, and divide that by a minus 2b, what's left over is plus 5b. And so the factored form is a minus 2b times a plus 5b. Alright? And if you want to do that for f, that's good too. You can take out the z minus 1. But wait, there's more that's perhaps common. I see both of them share a factor of 4, and they also share a factor of x. So that's great. And now the tricky part is what's this divided by that? Well, I think what's left over, 8 divided by 4 is just 2. X squared divided by x is just x. Y cubed divided by nothing is just y cubed. And then z minus 1 divided by z minus 1 is just 1. And then now, how about this divided by that? Aren't they the same things? When you divide by the same things, what do you get? Please don't say 0. But actually say 1, right? 5 divided by 5 is 1, not 0. So this actually becomes minus 1. Nicely done. Okay. Alright, here. The last one I want you to try on your own. This is the one where if you did the extensions from Unit 1, this will probably give you a good hand and trick to it. Otherwise, I guess you can't do this. But anyways, I want you to try. Think about the the volume of a sphere, and go from there. Okay? Press pause, and then got an answer, or you're stuck, then come back and check with me. Each of these tennis balls is a sphere. I'm going to call the radius r. So think about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This length here is actually 10 r's, where this width here is 2 r's, and this height here is also 2r. So if I'm asking you for the volume of the empty space, is the volume of the box minus the 5 tennis balls, right? Volume of the 5 tennis balls. Volume of a box, in this case, this is empty space, right? Empty space. 10r times 2r times 2r. 5 tennis balls, and each tennis ball has a 4/3 pi r cubed. That is correct. So in this case, 10 times 2 times 2, that's 40 r cubed. And here we have 20 over 3 pi r cubed. And if you have this as your answer, I'm really happy because you really understand what's going on. But it did say also to leave your answer in factored form, so let's factor. I'm going to take out an r cubed. And so you're left with 40 minus 20 over 3 pi. And that would be factored form. Alright? That's it for the first one. Lots of information here, I know. Review, please. This idea of factoring, so important in future